So today is going to be a little bit of a continuation of yesterday. And if you remember from yesterday, the whole point was to solve an absolute value equality. Okay? Now today, the only thing I'm changing is instead of an equal sign, it's going to be an inequality sign. So greater than or less than. So we're going to see how that's going to affect our work. All right? So I wanted to start by just asking you if you could give me answers to plug in for x that makes this true. And I want to plot them on this number line. Yes, Tyree, what do you got? 2. What's the absolute value of 2? Is 2 less than 3? Excellent. 2 works. Thank you, Tyree. Anybody else? Yes, Roberto. Negative 1. What's the absolute value of negative 1? 1. Is that less than 3? Yes. Yes, Gabriel. No, you were just saying that. Okay. George. Negative 5. What's the absolute value of negative 5? Is 5 less than 3? No, so that's wrong. 0. That one works too. 0 is less than 3. Any others? Yes. 2. We already did that one. Negative 2. The absolute value of negative 2 is 2, and 2 is less than 3. And I heard somebody say 1. All right? Now, there's a couple other, I should actually say there's infinite other points you guys are missing because it has to do with 3. What happens if I plug in 3? Is 3 less than 3? No. But what if I plugged in 2.9? Yeah, so I need to actually keep going, but what do I put at 3? An open circle. Very good, Margot. So what do you think I'm going to put at negative 3? An open circle. What should I do with these points? I should connect them because are the other real numbers in there solutions? Like 0.5, negative 3/4, do those work? Yes, they do. And if you think back to yesterday, when you have them coming together, what word do I use? And conjunction. Very good. So this is a conjunction. All right, so I heard we're going to use the word and. So watch how I write this. On the right side, I'm just going to write x is less than 3. Because if you look, I want the values that are less than 3. Does everybody see that? I'm moving to the left. What's going to go on the left side? X is greater than negative 3. Okay? So we went from an absolute value inequality to a conjunction, and I wrote the word and what is gone? What is no longer here? We never had an equal sign to start, though. The absolute value. All right, to tell me like we're directing a plane, right? Absolute value is gone. All right, just think back to yesterday when I made a big deal about it. When you write the words and or, and I see absolute value, I'm going to lose my mind a little bit, okay? So just keep that in mind. Everybody okay with this one? All right, let's try another one. Let's look at this one here. What are some values that would work for this? 4. So I put 0 here. 1, 2, 3, 4. 8. Yes? Negative 5. What's the absolute value of negative 5? Is 5 greater than 3? Yes. 5 would also work. So if you notice, I'm actually going to keep going this way, right? That's for you. Now, there's some other things I need to do in here, though, because it all comes back to 3. What's the absolute value of 3? 3. Is 3 greater than 3? No, so what type of circle goes at 3 again? An open. All right, and what should I do between the 3 and the 4? Connect it, right? Because again, 3.1, 3.2, those would work. What about over here? Negative 3 is an open circle, and I'm going to connect those two. And you should see from yesterday that this is making a what? A disjunction. So I'm going to use the word or. Yes, Tanya. No. You actually won't do that. I'm just showing you how this created something we know from yesterday. I'm just trying to show you that. Yeah.
So when it's greater than, it's a disjunction, and when you, right?
I mean, you just should teach the class. I love it. When it's greater than, it will always be a disjunction. When it's less than, it will always be a conjunction. Always. All right, that was going to be my next point, but, spoiler alert. Now, let's finish this. How would you describe this piece here? X is greater than 3, because we're moving to the right forever. What about when I move to the left forever over here? Aiden, yeah. Absolutely, yes. Okay. Everybody all right with this? Now, on the next slide, there's a nice table that summarizes our work from yesterday and the work from right now. Okay, so once you're done writing this, take a look at that next slide at that table. You got to push the black thing in. No, on the sharpener. As you sharpen. Nope. The face. Push the face. Okay. Sounds like it's going well. All right. So, this is the table I'm talking about. All right? Oh, so you can see it. This is the table I'm talking about. This is what we did yesterday. It was absolute value equalities. Okay? Can we put that away? Thanks. Absolute value equalities. And what word did we always use yesterday? Or. It was or. Okay? Now today we have two new ones. All right? George already summarized for us, but every time you see the symbol less than, it will be a conjunction. Anytime you see greater than, it will be a disjunction. So here is a kind of a silly way to remember it. I want you to think greater than. So if you see a greater than sign, you think or. And less than. So less than is and. I know it's silly, but it works. Okay, so greater, like you're in England. Greater, okay? I don't know, man. I've never been to England. Or less than. Okay? You guys ready to try some? All right, here we go. Let's try this example first. I'm going to ask the same questions that I asked yesterday. Is the absolute value by itself? Yes. It is. I don't see anything in front or behind it that's on that same side of the inequality. All right? So that's a checkpoint. Remember from yesterday? I've already got that checkpoint. Thank you, problem. You've already done some work for me. All right? Now, the question is, because yesterday it was always what word? Or. Today it could be or, but it also could be and. Okay? So I see this symbol. Greater than. Or. Okay? Now, on the right side, I'm going to write the same exact stuff, but what doesn't come down with it? Very good. I wrote the word or, which means no more absolute value. No more absolute value. So 2x plus 1 is greater than 5. You should see that's exactly the same as the problem. Just no absolute value. Exactly. If that's one thing you learned today, that's it, right? If you write the word or and, no more absolute value. Because what you're doing, Jose, is you know there's going to be two pieces here, right? Because there's an absolute value, there will be two pieces to my solution. So by saying or and, you're saying, okay, I don't need it anymore because I know there's going to be two pieces. All right? Now, does the 2x plus 1 change? No. Whatever's inside the absolute value, do not change it. Do not change the inside of the absolute value. All right? This symbol is greater than. What's the other symbol? Less than. So you're going to change it to less than. All right? Because we need to do the left piece. Yeah.
So whenever you have, like, when it's like that,
for
the other side, you have to change the sign?
Are you talking about this piece here?
Yeah.
Nothing changes here.
No, why did you change the sign?
Because if you remember from our example, we had the right piece, so the piece going this way forever, and then this piece going this way forever where the sign changed.
Oh, I wasn't there for that.
Okay, well, now you are. Yes?
I think I just answered
Okay, great. I love when I do that. Okay, so we changed the inequality symbol, and what do we need to do to the 5 as well? It needs to become the opposite, or negative. All right? I am looking for this step. So I'm going to circle it But you guys know that's not the answer. Is everybody on the same page? That's not the answer. But I'm looking for that step. Yes, Joseph.
So x wouldn't be the same for each one? It would be
Are you talking about when I get to my answer? Like x in terms of greater than less than a number? It may not be the same numbers, correct? Yeah. Doesn't have to be. It could. Doesn't have to be. All right. Is everybody good on getting to this point? Margot's question.
I remember in the last chart that you showed us.
Yes?
When absolute value equals
Like
number,
equals? Yeah. Mm-hmm.
it's always going to be an or.
Always or. Correct. Yes. But today, since we're not doing equalities, you might have or, and we'll do another example, you might have and. Okay? Is everybody good here? The next steps are not new. You've solved algebraic inequalities before, so we can do that hopefully fairly quickly. So how would I isolate the x here? Subtract 1 first. And notice, is it the same work over there? It is. So you can do this simultaneously if you'd like. All right. What's left after that? 2x is less than a negative, still a negative. And 2x is greater than positive 4. The last step to get rid of that 2, divide everything by 2. Both of these sides, by the way. All right, so we end up having x is less than negative 3. What word? Or x is greater than 2. Now that is the first piece of the answer, because I will graph. Yes, Tari.
So what if the 2x was negative? Would the sign still change back?
Yes, so if these would have been negatives and you divide by negatives, they should both flip. Correct, yes. Great question. So all those rules that you've learned still apply. Is everybody okay?
Yes.
Go back to.
so the signs always flip.
Are you talking about like this right here? Yes, the left side will always change the inequality symbol. And this should have become the opposite. Okay? All right, so if I graph it, I have this one which is moving to the left forever and to the right forever. Does that look like a disjunction, the word or? Yes, you always want to stop, pause. You'll be looking at your boards. Be like, okay, does that match up my graph and my word? My graph and my word, do they match? Okay? Questions on this example? All right. Let's try another one. Is the absolute value isolated? No, there's something else over there that's not in the absolute value because the symbols don't extend down into the denominator. So I have a division of 3. How do I move that over? Very good. I'm going to multiply by 3. So that means I have the absolute value of 2x plus 7 is less than or equal to 3. Notice my absolute value is still there. I'm not taking it away yet. Right? I was not ready to write a word, but here's my first checkpoint. That's my first checkpoint. Now I'm ready to pick a word. Yesterday it was always or, but this time you got to actually think, is it or is it and? The symbol is less than, less than, less than. So I'm going to use and. Okay? Now from here, the process becomes the same thing. On the right side of and, what happens? On the right side. Literally exactly the same. But please do not copy the beginning, right? At this point, I'm only working from this guy here. All right? That's what I care about. Jose. We're getting rid of it. Right now, right? This is the step. Once you write your word, and or, your absolute value can go away. On this side, 2x plus 7 doesn't change. But what should change about my inequality symbol? Greater than or equal to. Notice the equal to part still comes with it, right? So that won't matter. And it becomes negative 3. Don't forget both of those things. Yes?
The equal to sign won't affect your...
It won't affect, yeah. It'll just be at the end. Instead of open circles, they'll be closed. Yeah, Margo.
Can you explain again why we have to switch?
So I'll go back to the and Carolina, listen to this because you weren't here either for this one, I don't think. Okay? When we did this one, and I asked you, what does this look like? You told me a conjunction, so that's why I used the word and. This piece is values that are less than 3. This piece is values that are greater than -3. So when you go to the left, you switch the symbol, and the 3 becomes the opposite. That's why we do it. Okay? Yes?
Do you switch the signs for conjunction and disjunction?
Correct. Those are, you switch for both. And you also switch the number as well to be the opposite. Yeah, Jose. I'm almost done. Okay. Yeah, Aiden.
So after you flip the inequality sign, and like if you end up dividing by a negative, do you flip it back?
So are you talking, I think Tyree asked that. Yeah. If in my work I do divide or multiply by a negative, you still have to follow that rule. You still have to follow that rule. Okay? So let's finish this quickly. -7 from both. So I have 2x is greater than or equal to -10. And 2x is less than or equal to -4. Last step, divide everything by 2. Again, I'm not as worried about this. I feel confident in your abilities to do that. So x is greater than or equal to -5. And x is less than or equal to -2. And then you would plot it. Okay, so we'll plot it real fast. 1, 2, 3, 4, 5. Close circle. 1, 2, close circle. And how do I shade here for my solution set? Greater than, less than, so you're correct, in the middle. Does that match?
Yes.
All right, you always want to ask yourself, does it match my word? Okay? All right. So finish writing that down. Then I have a few things I want to say before you go to your boards.